Hello, everyone, and welcome back to the Serverless London meetup. We got two great speakers today, both AWS heroes. First up, we got Matthieu Napoli, who'll be talking about using the AWS CDK inside the serverless framework. And to follow that up, we have DeBrie talking about using DynamoDB inside serverless applications. If you've got any questions during these talks, put them in the chat because we'll do a Q&A session after each talk. And just before I hand over to Matthieu, I want to thank Theodo and Senzo for sponsoring. But from there, Matthieu, you can take it away and kick us off.
Okay, cool. So let's get started. So my name is Matthieu Napoli, and I believe making web applications should be simpler. So if you're here, you probably know about serverless. I love serverless too. It's so much simpler to run applications online, not having to deal with servers, managing them, configuring them. It's great. But I still think there is a way to go to make applications simpler. And let me explain that for a minute with code. Over the last 20 years, development has changed so much. We started with languages that allowed us to basically make anything. And then we had some reusable pieces of software, libraries, module, however you want to call it, with the package managers. And all of these helped us make these things more quickly, more easily. But that wasn't the end. Now we have frameworks, and frameworks come with best practices. They come with architecture. They help us make it right. We know that when we use React, Express, Django, Rails, Laravel, we know we are on the right track because we are using the architecture provided by the framework. That's the landscape on the development side. But on the infrastructure side, I believe infrastructure frameworks are overdue. We need them. Yes, we have languages to make anything. We have infrastructure as code like CloudFormation, we have Terraform, and we have so many alternatives. We even start to get, and it's been actually a while, we start to get libraries or reusable pieces of architecture of infrastructure like CDK constructs, Terraform modules, and so on. But so far, we have very little infrastructure frameworks that guide us, that provide us with the architecture to make things right. If I want to create a serverless API, a website, a job queue, a webhook, deal with file uploads, I still need most of the time to build it myself. And that's where I think infrastructure frameworks could help us do it correctly by providing with the best practices, the architecture to do that. That's the idea behind Lift. Lift is an open source project that brings high-level use cases to the serverless framework. Those use cases are called constructs. And you may have heard of CDK constructs. Yes, we'll talk about that. I'm talking about use cases like building websites, deploying job queues, creating webhooks, real end-user use cases. Internally, Lift uses CDK constructs. So Lift integrates the CDK, the AWS CDK, inside the serverless framework. Now, constructs in Lift, like websites, job queues, they are implemented with the CDK. Whenever we run serverless deploy, Lift will compile those use cases into actually CloudFormation using the CDK, and will insert that CloudFormation into the deployed stack. So everything works as usual, one serverless deploy command, and everything is online. Lift is a plugin, so I want to show you a bit how it works. First, just like any serverless framework plugin, we install it with npm, for example, and then we have to enable it to register it inside serverless.yaml. We can use Lift with functions, with anything else that already exists in the framework, and we can enhance that with constructs. So let's enable Lift, and let's have a look at the first construct. I will start with a very simple one, not really high level, but I think it should help to illustrate how it works. Storage. Let's say I want to store files. I will be using Amazon S3, I will be using an S3 bucket, of course, but then I have to configure it and I have to deploy it. Lift provides a new section in serverless.yaml, which is called constructs. And that's where we define whatever we want to deploy with Lift. In my example here, I'm creating two S3 buckets, one for storing invoices, one for storing PDF reports. That could be anything really. And then when I run serverless deploy, those 4 lines of YAML will turn into CloudFormation automatically, transparently, and these buckets will be created. And the thing is that, if you've created buckets in serverless.yaml, you can write custom CloudFormation, and it's not that hard. Lift isn't there. It's there to simplify stuff, but it's also, and more importantly, there to solve decisions, provide best practices, guidances. Lift constructs are production ready, which means that when I deploy an S3 bucket, it's not just about creating the S3 bucket. It's about making sure it is ready for production. And that means, for example, enabling encryption at rest, so that any data stored in the bucket is stored encrypted. Without any impact to the application, we don't have to change anything. It's just there by default. That way we comply with company policies, government policies maybe. We also have by default file versioning enabled, so that way we can avoid any accidental data loss. Let's say I delete a file by accident, or I overwrite some data. With file versioning, I can retrieve all the versions of my files and restore them, and I have like 30 days to do so. Lift also enables automatic purging of those old versions, those old backups. That way I don't have extra cost for nothing, for no reason, sorry. And finally, Lift provides cost optimization by default thanks to S3 intelligent tiering. So to be honest, before working on Lift, I've heard about these things, but I've never used them because creating a bucket was as simple as putting 2 lines of YAML in CloudFormation. But then when you want to make it right, it's suddenly much harder, and that's what we want to solve with Lift. Now we have some good production defaults, but that's not it. We have a bucket, but we want to use it. Let's say I have a Lambda function and I want to be able to read and write files from that function. That's where variables come into play. Forget about CloudFormation, forget about CloudFormation references. It's all done for us thanks to variables provided by Lift. So let's imagine I have one construct and I have one function. How do I get the bucket name? Well, I can inject the bucket name in an environment variable using Lift variables. So I can easily reference the invoices construct and get the property bucket name on that construct. If you know about the AWS CDK, it may look familiar, but if you don't know about the CDK, that's okay. You don't have to. You don't have to know about CDK. You don't have to know about CloudFormation. Just know that, and that's documented, of course, in the documentation, you have properties available on constructs and you can use them to get values. Of course, whenever we run serverless deploy, these variables are replaced with CloudFormation references transparently. Now that's one thing, but then we have to deal with permissions because my code on Lambda needs to access the bucket. And by default, whenever I create a bucket, nobody can access it. Well, in Lift, whenever we deploy something, Lift will pre-configure it, pre-configure the permissions. So here, I don't have to do anything. All the Lambda functions in my application, so in the same application, will have access to the bucket. The idea is that if you deploy a bucket, then it's probably because you want to access it, like read and write. So that's why Lift enables that by default. But you can, of course, set up your own permissions if you prefer. So that was the storage construct, but we have more constructs. Let's have a look at another one, static website. So the static website construct is, as you can guess, you can deploy React applications, Vue.js applications, but also any static website with HTML and CSS with 3 lines of YAML. Here, I'm creating a landing page using the static website construct. And the only thing I need to specify is the directory where the website is stored on my machine. That directory here is public, but it could be anything. If you're using React, it should probably be build. If you're using Vue.js, it should probably be dist. It doesn't really matter. And whenever I run serverless deploy, well, Lyft will compile that into CloudFormation and will deploy an S3 bucket to store the static website and to serve the static website, and also a CloudFront distribution, which is a CDN, and that CDN will cache the website all over the world, cache the images, the CSS, everything. CloudFront will also provide HTTPS support, custom domains, and everything. So that's what Lyft will deploy on serverless deploy. But Lyft will also take care of uploading the website on serverless deploy. So it will create CloudFront, create S3, and upload all the static files just in one command, in one serverless deploy command. And whenever the deployment is finished, I get the URL of the deployed website. Now, of course, this is a CloudFront URL. I can change that. I can put a custom domain. Lyft constructs have options, and I can change a few options. So I can set the custom domain. I also have to set the HTTPS certificate. So if you don't know about that, that's fine. The Lyft documentation explains how to create it, but that's how you can override that to deploy a custom domain. And then we run deploy again, and Lyft will show the new URL with the custom domain, and it will also show the CNAME so that you can create the DNS entry very easily for your custom domain. Remember, Lyft constructs are production ready, so the static website will be configured by default for production. It's not just about making it work, it's about making it right. So for static websites, we automatically set up HTTPS with CloudFront, the HTTP to HTTPS redirect as well. We have the CDN that will cache all our websites all over the world. Cache is configured. Anytime we deploy, Lyft will invalidate the CloudFront cache as well. So this is all taken care of. Lyft also deploys CloudFront functions to set recommended security headers. So this is a set of HTTP headers that is set on responses. And that's about it. Now, the final example I have is about job queues. Job queues, message queues, however you want to name it, it's the famous SQS plus Lambda combination. If you've deployed SQS plus Lambda, especially using the serverless framework, you know it's not that complex, but getting it right for production is really another business. So with Lyft, we have a queue construct. Here I've named it jobs. And what we have to define is, so the construct deploys an SQS queue, but it also deploys the Lambda worker that will process messages from the queue. So here, my worker section is exactly just like any function defined in serverless.yaml. I can set the handler, but I can also set the timeout. I can set the memory size, the runtime, anything that I want. And on deployment, we will get SQS plus Lambda automatically configured to process the messages from the queue. But again, production ready doesn't stop there. We have to think about failures, about retries, and that's why that construct deploys SQS, Lambda, and a dead letter queue that will store failed messages. It can also deploy for you an alarm that sends an email whenever there's a failed message in the dead letter queue. Those patterns are built based on AWS recommended architectures, based on experience from experienced AWS builders. That's how we get production-ready job queues. Job retries are configured by default. Lyft configures the SQS visibility timeout properly per Amazon's recommendation based on the Lambda configuration. Failed jobs are automatically stored in the dead letter queue, and we can deploy SNS and a CloudWatch alarm on failed jobs. Now, just like with S3, we can use variables because I have a function where, like the publisher function, where I can send messages to the queue, and that function needs to get the queue URL. So I can inject that queue URL using a lift variable, using a property on the construct. And again, permissions are automatically configured. The idea is that if you deploy a queue in your application, it's probably because you want to send messages into it. So by default, all your functions of the same application, and only from the same application, can push into the queue. Finally, there is one last feature that I haven't talked about: commands, custom commands for constructs. So with the queue, you have a few set of commands that you can use to administrate the deleter queue. The first one lets you list failed messages from the deleter queue. So here I'm listing the failed jobs from my jobs queue, and I can see that I have 2 failed messages. And those are messages that were retried and retried and retried again, and they failed. So they were moved to the deleter queue. Now I have a choice. I can delete those messages, like purge the queue, or I can retry them again. So let's say I check out those messages and I find there's a bug in my code, so I fix it, I deploy. Now I want to retry those messages again. Well, there's a command for that, and it's the retry command on the queue construct, and that lift command will take the messages from the deleter queue and move them onto the main queue, and that way these messages will be processed again, and that's it, we're done. So those are construct level commands. So this was just an overview. This is lift. I guess you get the idea here. The project is open source. It's on GitHub. It's being incubated by Serverless, where I work, and Theodore. I work on that project with Frédéric from Theodore, and we are having so much fun, especially talking with you, understanding your needs. So if you have feedback on that, if you are thinking about new constructs, things that may be missing from these existing constructs, please get into the project, participate. We have discussions where we exchange over the needs. If you're interested in trying it, check out the project on GitHub. And if you have any question, I'd be happy to answer it. Thanks a lot for watching.
Thank you, Matthieu. That was a great talk. So anyone, if you do have any questions, feel free to still put them in the into the chat. But while we wait for any of those, Matthieu, I was just wondering, I've not actually had a chance to use the CDK yet, but I know it's a lot of controversy about whether your infrastructure as code should be declarative, or whether pushing towards stuff like the CDK is the right direction. How have you found using it?
The CDK is amazing, really. It's an incredible piece of software. So at first I was kind of skeptical because I've been using CloudFormation for a long time, and I wasn't sure why writing some CloudFormation in JavaScript or in TypeScript would be any different. But it turns out it's extremely powerful, and using it is like you feel very, very powerful, But the real big downside is, again, it's complex, and for me, it's not meant to be used by everyone. If I want to build a website, I don't want to get into the CDK. It's just too much. So that's why I really love this approach, this middle ground where we build high-level use cases with the CDK, and it's extremely enjoyable to do. And then we get all these nice features, and we can expose them very simply with a few lines of YAML.
It does sound really nice. For the developers using these constructs you've made, how much control do we have to change them, or is it they're pretty set when you use them?
Yeah, they are pretty set. We are trying to make it a bit opinionated. We have some options, like you can change custom domains, you can change some headers, options that will grow and become more. We'll have more options with time. But what we are exploring as well is letting users create their own constructs. So usually, in a team, you may have someone that is like a DevOps profile, someone that would love to get into the CDK and build something very specific for the team. But the rest of the team, they are developing. They don't really care about CloudFormation details and CDK details. So I think there could be something interesting here where we could have advanced user build their own constructs. either publicly or privately, and then having users just use them as simply as possible.
Yeah, the abstraction does look really nice. When you're coding with Lyft, does it still feel like you're writing serverless framework YAML, or does it feel a bit like you're writing more Lyft code?
That's a good question. There are some things that we are, changing in terms of convention, because as soon as you're thinking about, we talk about a construct-oriented design, where you have properties on each construct, whereas with functions it's a bit different. So some things are a bit different, but we are trying to tie it together with the existing framework. That's not always easy, but that's what we are trying to do.
Yeah, no, it does sound like it would be quite the challenge, but I look forward to giving it a try soon. But thank you so much for giving us the talk today. Next up, we'll bring Alex on, but we'll talk to you later, Matthieu. Bye. Welcome, Alex. If you want to present your screen, I'll let you take over.
Absolutely. Okay, let's see. All right, here we go. First of all, great talk by Matthieu. That was very exciting. Longtime fan of the serverless framework here, and excited to see some of the new stuff coming on. And also, I'm just very passionate about simplifying stuff for folks. So that was cool. Excited to see where all this stuff is going. I'll be talking about a different kind of simplification, hopefully simplifying some of your database management and things like that. So let's just hop right in, right? So this is a Serverless London user group, and so if you've been around this world for a while, you're probably familiar with this serverless pattern. And when we're talking about serverless, it often starts with something like AWS Lambda, right, which was released at reInvent back in 2014, 2015, somewhere around there by Werner Vogels, right? And pretty awesome. You have this hyper-ephemeral, stateless, function-based compute, pay-per-use, scales to whatever. But Lambda by itself is not going to do a lot for you, right? Because it's stateless compute. You often need to do something with it. You need to trigger it in some way. So then you reach for something like API gateway. You can hook up an HTTP endpoint to your Lambda function and do something, right? So now someone on the internet can call your function and get some result back. But again, Lambda by itself with API gateway is usually not enough, because usually you've got some state associated with it and you need to store that state somewhere or retrieve it from somewhere else. You might hook up something like Amazon S3, right, to do some blob storage. Maybe you want to store some files there or something like that. Or you use something like SQS, and Matthieu showed an example there of putting stuff into SQS with that queue construct they had. Maybe you want to put it in one of these sort of like pub sub like mechanisms that Amazon has, like EventBridge or Kinesis or SNS, all these great tools. But in a lot of cases, you need a database somewhere. And even within the database world, there are a lot of options. So Amazon has RDS if you want a relational database service. They have DocumentDB if you want MongoDB. And then they also have DynamoDB, right, which is this fully managed NoSQL database that they run. You can only get it on Amazon. And that's what I'm going to talk about today, using DynamoDB in serverless applications, because I love Dynamo, and a lot of folks using it in the serverless world love Dynamo as well. So 3 things I want to talk about today. Number 1, why DynamoDB and serverless? We're seeing a lot of people that are building serverless applications reach for DynamoDB. What's going on behind that? What are the reasons to choose Dynamo if you're building serverless applications? Once we've done that and sort of looked at the non-data model sides of why people are choosing Dynamo, right? Some of the operational sides or the mechanics. Then we'll go into basics of DynamoDB data modeling, because data modeling with DynamoDB is quite a bit different than with a relational database. So we'll take a look at what that's like, how it's different than other databases, some of the terminology, some of the concepts, and things like that. That's a little bit theoretical, so then we'll bring it back down to earth with talking about one-to-many relationships and how you can handle that in DynamoDB. And I think it helps sort of hammer it home, especially if you're new to Dynamo and you're swimming a little bit from that second section. So who am I? I'm Alex DeBrie. I wrote the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. Also created DynamoDBguide.com, which is a free resource if you want to go check that out. I'm an AWS data hero. Used to work for Serverless Inc., like Matthieu does now. So just been in the serverless world for a while. Just a big time AWS and serverless fan. I mentioned the book. It's a It's a guide to data modeling with DynamoDB, 450 pages and extras, and it has 5 walkthrough examples. So you can do really complex data modeling with Dynamo. I got an example of how to do the whole GitHub backend. So if you want to do organizations and users and repos and issues and pull requests and comments and reactions and all that stuff, you can see how to do it in DynamoDB. So go check that out, free sample, all that stuff. So anyway, let's get started with the fun stuff. Let's start off with why DynamoDB and serverless, right? DynamoDB is kind of blowing up in the serverless world. Why are people choosing it? I think there are 5 or 6 things going on there. We'll just run through those quickly. Number one is just the interaction mechanics, right? I I showed at the beginning of this talk about how you're using all these different serverless or services, in your serverless applications. You're using S3 or SQS or things like that. And using Dynamo is pretty similar to working with those. So let's take a look at what it looks like to interact with a service, an AWS service in your application. This is a Python-based example, but you can, it's the same for JavaScript or whatever you're using. But if you're interacting with something here, it's SQS, it's generally going to look something like this, where you import the client library, which is Boto3 in Python. It'll be the AWS SDK in the other languages. You'll import that library, you'll create a client, and then you'll call a method on that client. So here we're sending a message to a particular SQS queue. And if you go look at S3, right, you need some blob storage, very similar mechanics there. You have importing your library, creating that client, calling that method on that client. And if you look at DynamoDB, the exact same mechanics you're going to get there. Importing that library, creating that client, calling that method. And it's just sort of familiar what you're doing with DynamoDB in your serverless applications. If you're already using AWS services, it feels very familiar and natural to use DynamoDB rather than, some of the relational libraries for interacting with a relational database. You've got connection pools and all kinds of different things and cursors and different things like that. It feels very natural to sort of keep using what you're using in your serverless applications here. So that's reason number one. A couple more related reasons that are, it's saying Dynamo is similar to other AWS services is the permissions model with DynamoDB, right? So if you're working with a serverless application, here's some serverless.yaml here, just like we saw with Matthieu's. But if you're working with serverless applications, you need to set up IAM permissions for your functions here. So if you want your function to be able to write to an SQS queue, you're going to set that up with that IAM role statements and say, hey, allow SQS send message on this particular queue. And if you're working with DynamoDB, it's going to be the exact same familiar syntax, right? Here, I want to allow get item, put item, query on my specific DynamoDB table. So again, you're just learning sort of one set of permissions here. You're using IAM, which is already sort of baked into your Lambda function. So the nice thing about the Lambda permissions model, right, is you're going to associate a role with your Lambda function, and every time they spit up a new function instance, they'll just create some temporary credentials, inject it into that Lambda function, and those credentials are automatically discovered by the SDK. So you don't need to worry about credential management, any of that stuff. When you're thinking about Lambda, all you need to do is say, hey, what permissions does my Lambda need? What are the permissions I need to add to this role to handle this stuff? And you're already using IAM elsewhere, so it feels very familiar. So that permissions model is similar. Next thing is about the provisioning model, right? If you're using serverless applications, you're using some sort of infrastructure as code. It probably looks something like this. If you're provisioning that SQS queue, you're using CloudFormation in some form or fashion, likely, and it's going to look like this. Provision that SQS queue. Provisioning DynamoDB is going to be very similar in that same way, where you can just provision it very nicely with CloudFormation. If you're using something like a relational database, maybe something in Amazon RDS, you can provision that database in RDS, but you also need to provision a lot of related infrastructure, like all the networking, things like that. And additionally, there's some things you can't really provision well in CloudFormation for a relational database. Like it's hard to sort of initialize your database with the tables and the indexes that you need, with the users that you need and the permissions on those different tables. You also need to figure out how to get those users out of your table and store them somewhere else so they can be managed and used by your Lambda function. So there's sort of this two-step you need to perform if you're using a relational database that you don't need to do with Dynamo. Everything in Dynamo you can provision in CloudFormation and it's going to work for you. So that works really well. Infrastructure as code is a huge part of serverless applications. It predates serverless applications, but I think it's really taken off with serverless applications just because you cannot effectively have a serverless application if you don't have infrastructure as code, because your infrastructure is part of your application in a way it wasn't before, right? Your SQS queues or your DynamoDB tables or your Kinesis streams, all those things are sort of part of your application and a little bit faster moving than infrastructure in the old world. So Main tools are going to be, CloudFormation and Terraform here. In the serverless world, CloudFormation is kind of the winner, I think, just because of the tooling that's been built on top of it to make it easier. Whether you're talking about Serverless Framework or SAM or CDK or Begin or Arc.codes, anything like that, all those built on CloudFormation. And the great thing about infrastructure as code is it's repeatable, right? And you can sort of deploy this over and over, and it's only going to fix what changes. You can also make high fidelity staging environments, things like that. So infrastructure as code, very popular in this serverless world. Next reason people are choosing DynamoDB with serverless is the billing model. So the billing model with DynamoDB is pretty interesting, right? In the serverless world, we like this pay-per-use billing model where you have, you're only paying for what you actually use. And I think Dynamo fits with that in two different aspects, right? First of all, with Dynamo, you're paying for reads and writes directly rather than resources. So if you think about a relational database, what you're paying for is this instance that you provision ahead of time, and you're saying, I need this much CPU, this much RAM, this much disk space, and they'll give all that to you, and you're hoping that's enough to sort of satisfy your queries. But with Dynamo, you're not sort of paying for raw resources, you're paying for the ability to run queries against it. So Dynamo, you're paying for what's called RCUs and WCUs, read capacity units and write capacity units. And basically, a write capacity unit allows you to write 1 kilobyte of data to DynamoDB, and a read capacity unit allows you to read 4 kilobytes of data from DynamoDB. And the nice thing about this is, if you're doing capacity planning, you have to think how many users, how many requests I'm going to get, and then how big are those requests going to be. In that traditional database world, you have to sort of, once you figure that out, you need to translate it to CPU and RAM and IOPS and all that stuff. And you're like, how does that really work? Whereas Dynamo, if you can estimate roughly the number of requests and users and how big each of those queries are going to be, you can calculate pretty well what the RCUs and WCUs are going to look like on your table, which is really nice. So that's the first way. The billing model is really interesting. The second way is they have these two different billing modes. So the traditional billing mode is provision capacity, where you determine upfront, hey, this is how much RCUs and WC units I want to have and actually use in my application, sort of similar to a relational database, although again, you're not paying for like the raw resources. But the second billing model, so this is a newer one, is on-demand billing, so pay-per-use billing. And you can say, I don't want to tell you how many reads and writes I'm going to have. I'm just going to execute writes against my database, and you charge me for each individual one on those. And that on-demand mode is a little bit more expensive than the regular mode if you have like a fully utilized provision capacity table. But in reality, it's really hard to fully utilize your capacity, right? First of all, it's hard to estimate, so you probably over-provision. But then also, you just have ebbs and flows, within the day, within the week, within the month, over how much usage you're actually using. So in a lot of cases, that on-demand mode can save money compared to that provision capacity mode, and you just don't have to worry about as much, don't have to do as much capacity planning, things like that. So billing mode is huge for DynamoDB. The next thing that's really nice about DynamoDB is like the development environment, right? Not only is there a local development mode that you can run DynamoDB local if you want to run things locally, but if you have infrastructure as code, if you have all these serverless services that are all pay-per-use, Lambda, DynamoDB, API Gateway, it's very easy for you to have like a high fidelity developer environment that's just like your production environment, right? So you can deploy it to a different account or a different space in your current account and just run that entire stack and play around in there, and what you have locally is exactly what you're going to have in prod. You can have nice confidence in that. And because these things are all pay-per-use, if you're just running it for local development mode or test mode, that's going to cost you like less than $1 a month. It's not going to cost you anything. You can put it on your company's credit card to pay that bill, and it's just not going to be anything. So every person on your team can have a local, or not a local, but like a high fidelity replication of prod, on their own AWS account, which is great. And then finally, the last thing about DynamoDB that's really great are the scaling characteristics of Dynamo. And one way I like to show this is with this chart, where on the x-axis there we have our data size, right? And as you go further out on that x-axis, your data size is growing. So maybe at the beginning, you just have a gig or 10 gigs of data, but eventually you get up to 100 gigs, a terabyte, things like that. And then on the y-axis, you have performance, or you can consider this as like latency, right? Where higher is going to be worse. So you have blazing fast, sluggish, and painful. And this won't be very scientific, but I think this will give you a feel for what performance looks like, right? So if you have a traditional relational database, your performance curve is going to look something like this, right? Where when you deploy that application or for the first time, you release it to your first users, or you're running it locally, or running in staging, it's going to be blazing fast, right? You don't have that much data. It all fits in memory. Everything's going great. You have everything indexed. Queries are really quick. But 6 months down the road, a year down the road, you have more users, you have more data, and now it's getting sluggish, right? You have users that are complaining, or you notice it when you're sort of using the thing for yourself, and you have to go investigate. Hey, do I need to add more indexes? Do I need to increase my database size? Do I need to denormalize some data? Different things like that. And that can work for a while, but you might get to the point at some point where it's so painful, it's so bad, you've tried all these different things. Now I need to go and re-architect and either remove some features or just change how I'm doing things, and that can be a pain. So that's going to be your traditional performance curve with a traditional relational database. With DynamoDB, your performance curve is going to be more like this, where it's completely flat. You're going to get the same consistent performance on day one in your staging environment as you do, 5 years, 10 years down the road. It's going to be very consistent performance throughout. It's not going to get slower as your data size grows, which is a nice benefit of DynamoDB, and allows you to keep working on new things, right? Rather than having to go back and sort of tinker with old things and change them and have this drag on you all the time. So that's the last thing, just those scaling properties of DynamoDB, I think, are really nice for these serverless applications. So now we've talked a little bit about, why people are choosing DynamoDB in serverless applications. And again, none of these have to do with a data model or sort of needs of the application. These are all sort of operational type things or convenience type things, right? Why people are choosing Dynamo for that. Let's get into a little bit about basics of data modeling and understand how DynamoDB is different than traditional relational databases. And we'll start off with vocabulary. So I just want to talk about 4 terms to kick us off here: table, item, primary key, and attribute. I'll run through these with an example here. So imagine we have an application that stores some users, right? They create a username, they log in, different things like that. We might have our data here. We have 4 different records. I have myself, and then a few folks that work at Amazon. We have Jeff Bezos, Jeff Barr, Warner Bros., things like that. If you look at all this data together, outlined in red there, that's going to be called a table. So similar in some ways to a table in a relational database, or like a collection in MongoDB, but different in other ways as well. If you look at an individual record in our table, that's going to be called an item. So comparable to a row in a relational database or a document in MongoDB. Now, when you create a table in DynamoDB, you have to specify what's called the primary key. And every item that you write into your table needs to include that primary key. And that primary key needs to uniquely identify each item. So you won't have 2 items that have the same primary key. That would just overwrite each other if you did that. So you can see here on the left, I've outlined the primary key. In this case, it happens to be username, right? Because each user will be uniquely identified by that user. We won't have 2 users with the same username. In addition to that primary key, you can write other attributes to DynamoDB. So I've shown these out here. Similar to columns in a relational database, with the big difference being you're not going to specify these attributes up front on your table, right? DynamoDB is a schemaless database, so it's not going to verify and validate the schema of your table outside of that primary key that we talked about already. So that doesn't mean you shouldn't have a schema in your application, but where that schema lives is going to be in your application code. You're going to need to verify before writing it. You're going to need to validate when you pull it back out, but DynamoDB is not going to do that for you. Also, every attribute you put into DynamoDB is going to be typed, and you can use types like strings or numbers or binary, right? Simple types, or you can use complex types like lists or sets or maps. You can get some sort of denormalized, complicated, complex data into your table. I want to talk a little bit more about primary key, because primary key is going to be very important in DynamoDB and in how you model your data, how you use your data in DynamoDB. There are 2 types of primary key with DynamoDB. First, there's a simple primary key, which has just a partition key. And there's a composite primary key, which has a partition key and a sort key. So the example we already looked at, that was an example of a simple primary key. It had just a partition key, which was username. If you're using a table with a simple primary key, it's great for key value type access, and that's it. You can only operate really on 1 item at a time if you're working with this sort of table. So it can work well for simple access patterns or caches, things like that. But if you're doing a complex application, you're going to be using a composite primary key. So here's a table with a composite primary key. I've outlined it in red here. I've got that same data, but what I've done is I've taken that primary key and made it two parts, right? The partition key is going to be the employer, and the sort key is going to be the username. And so if you look at this, me, myself, I'm employed by DeBrie LLC, my entity, and then there's also Amazon Inc. that employs these other folks. A couple things I want to note here is, I mentioned the primary key needs to be unique for every item in your table. When you're using a composite primary key, it's the combination of the partition key and the sort key elements that need to be unique. So you can see 3 items here that all have the same partition key of Amazon Inc., but that's okay because they have different sort keys, so you could access those differently. They're all going to be sort of unique based on that. We're going to talk a little bit about some concepts behind DynamoDB, but I think the most important thing you need to know is what I call DynamoDB's guiding principle. And this isn't in DynamoDB's documentation anywhere. This isn't in their marketing material, anything like this. But I think it underlines every product decision they make, what features they put in and what features they leave out. And that guiding principle is do not allow operations that won't scale, right? You remember that chart I showed you earlier showing that performance curve where it's got the flat performance curve over time, no matter the size of your data. And the reason behind it is this guiding principle, right? They do not want to allow operations that won't scale. They want to constrain you in ways that you can't write an application that won't scale. So what they're going to do is sort of limit certain things you can do. So that's what leads to this chart here. Again, has that flat performance curve from DynamoDB. So given that, let's talk about SQL versus NoSQL and some of the differences in DynamoDB's flavor of NoSQL to accomplish that main guiding principle of do not allow operations that won't scale. There are 2 main principles and then some implications based off that. So the first principle is just the importance of primary keys. So we talked about primary keys earlier, the different types of them, but they really are important with your data modeling, with your access in DynamoDB. If we go back to our users table that has that composite primary key of employer and username, when you're accessing items in this table, you're going to query based on that primary key. So based on how this table is set up, it's very easy for me to say, hey, go get Alex DeBrie that works for DeBrie LLC, or go get all the users that work for Amazon Inc. However, you don't query with your other attributes, your non-specified attributes. So things like first name, last name, email in this example. In this table, it'd be very difficult for me to say, hey, go give me the person whose email is jeff@amazon.com, right? It's just not set up for that. It wouldn't be efficient operation in DynamoDB. So importance of primary key, that's point 1. That's going to be very important when you're working with Dynamo. Number 2 is there's no join operation, right? So if you're used to a relational world where you normalize all your different tables and then you join data together with that, and DynamoDB does not have any join operations. So based on what's going on here, importance of primary key, no join operations, why is Dynamo doing that? And I think it's worth understanding how Dynamo works behind the scenes, right? So Dynamo isn't some sort of like magical supercomputer that's faster than anything else, and that's how it can scale. What they're doing is just using basic computer science principles. So you might think of Dynamo as like a simple machine, just like a relational database where all the data is on one machine, but that's actually not what's happening, right? If you have a DynamoDB database, what they're going to do is split your data into what are called partitions behind the scenes. And each partition is going to hold up to 10 gigs of data. These could be on different nodes all over the place, but they'll just segment your data into these 10 gig chunks and put them on different partitions. Now, when a request comes into DynamoDB, let's say we want to do a put item request. So we want to insert a new record into our users table. And we say, hey, we want to put Andy Jassy. He works for Amazon Inc. How do we put him in here? What's going to happen is that blue thing, the Dynamo logo there, it's going to hit the request router front end. And the first thing DynamoDB is going to do is look at that item you're writing. It's going to look at the partition key, which in this case is employer, and it's going to hash that value. And then it's going to say, hey, to which partition does that belong? So in this case, this item belongs on partition 1. It's going to go to partition 1, write that value there, and then return to the client. Now, the great thing about this is it's very easy for me as my data grows to add a 3rd partition or add 6 more partitions or add 1,000 more partitions. This is going to scale very nicely because that first step where it's hashing that partition key value and figuring out to which partition it belongs, that's a constant time operation, right? It's hashing that value and then doing a lookup and a hash map to figure out, which partition it goes to. So if you have a table that's 10 terabytes of data, right? The very first thing it's doing is hashing, finding that partition and narrowing your 10 terabyte search space down to a 10 gigabyte search space. So it's going to give you that consistent performance no matter how many partitions you have behind the scenes. And I talk about these partitions because I think it's useful to understand DynamoDB and what's going on, but you don't actually need to know about partitions, right? Dynamo's handling all this behind the scenes for you. They're adding partitions, they're moving data around, all that stuff. So you don't need to worry about this, but it's helpful for understanding sort of the scaling properties of DynamoDB. So we know those two sort of key points about Dynamo. What are the implications of Dynamo and of data modeling with Dynamo, and especially compared to a relational database? So first implication is a thing called secondary indexes. So let's go back to what I was talking about with the importance of primary key, how you're querying, with those primary key values, but you're not querying with those other attributes, right? But what if you have an access pattern where you need to access by that email? How do you do something like that? You can set up on your table something that's called a secondary index, and it's going to sort of take the data from your main table and reshape it, make a replica of it somewhere else that's organized according to these new attributes you've declared on your table. So if I want to create a secondary index on email, what I would do, I'm going to show what that secondary index view looks like. We have it over here. So we have the exact same data in our table, but now we have the primary key as a partition key of email that allows for quick lookups on email rather than on employer and username like we had in our table before. So secondary indexes, very useful in DynamoDB. Again, what's happening there is data from your base table is being copied into your secondary index with a new primary key, and it allows for these additional operations on that table. What you can do is you can use the query or scan. So you can use read-based operations on that secondary index, but you can't do any writes on that secondary index. All the writes need to happen to your main table, and then those writes will get replicated out to your secondary indexes that you can read from. So that's the first implication. Secondary indexes, very important to data modeling in DynamoDB. Second thing about DynamoDB is you need to know your access patterns in advance. And this sort of flips people, throws them for a loop, because if you're coming from that relational world, again, you think sort of entities first, right? You normalize all your data, put them in these different things, you hook up your primary keys and foreign keys, and maybe your joining table if you have a many-to-many relationship. Then once you've done all that, you're like, okay, how do I write my queries? How do I write my SQL to join all these different tables, add some indexes, things like that? Then I think about my access patterns after I've modeled my data. With DynamoDB, you got to flip that. You got to think about your access patterns first. Once you think about your access patterns, then you design your table to handle those access patterns. And that, again, that's because those primary keys are going to be so important. You want to model your primary keys to handle those access patterns for you. So know your access patterns in advance. The third implication, this is where people really start to get thrown, is you're often going to put all your items into a single table and use generic attributes for your primary key. So if you've heard about something called single table design with Dynamo, this is exactly what we're talking about here. Again, might throw you for a loop. The examples I've done before haven't used single table design, so now we're going to walk into it and hopefully walk into it kind of gently so you get a sense of what's going on here. So I want to use an example. Imagine we're building a SaaS application, right? We're building something we want to sell to people, and we want to model out two different entities, right? We want to model out organizations where that's who actually signs up for our SaaS application. They're the ones who pay the bills, something like that. And then users that act on behalf of an organization, right? So if you sign up for some new SaaS service, your company pays the bill, and then you have users within that are admins or members or things like that. So we're going to model out those two entities here. I'm going to start with a table that has just the organization. So I've put two organizations in my table here, Berkshire Hathaway and Facebook. A couple of things I want to call out here because this looks kind of weird. Number one, let's look at our primary key and specifically the name of our primary key attributes, right? Instead of using something like organization name, I've given it very generic names for these ones. So partition key is just called PK. Sort key is just called SK, right? And very generic names. And the reason is if I put different entity types in this table, like organizations and users and other things down the road, they're not going to share the same types of attributes. So it wouldn't make sense to put organization name and username for the partition key and sort key names. So we use these very generic values there. The second thing is, if you look at the actual values for the partition key, they're kind of weird too. Often what you'll have is sort of a template for each type of item. So this is an organization, and the template happens to be org hash and then the organization name, org hash Berkshire, org hash Facebook, right? And we're going to use that for every single organization we do. It's going to be useful for a couple different reasons, preventing duplicates between different types of items if they happen to share the same sort of identifier. also help for organization and help you understand what different entities you're working with here. So that's what we have going on here. Let's add some users into our table now. So this is our table now. We already had our 2 organization in there, and now I've added these 3 users outlined in red. So I have Charlie Munger, I have Warren Buffett, they both work for Berkshire, and then I have Sheryl Sandberg for Facebook. A couple things to note there. Just notice how the primary key pattern is different for those, right? They have the same sort of partition key pattern that they had for organization items, but then the sort key pattern is different. It's user hash username, right? The other thing to note there is just look at the attributes themselves. The attributes on the users are different than the attributes for the organization. So a user has a username and a role, where an organization has the organization name and the subscription level. Each of them have attributes that matter to them, right? And this is that schemaless nature of DynamoDB, where you're sort of enforcing that in your application layer rather than in DynamoDB itself. One last thing I want to talk about is this concept called an item collection. All the items that share the same partition key are said to be in the same item collection, and it's very efficient to capture those items that are in the same item collection. And it goes back to what we were talking about here. Remember, when a request comes into Dynamo, what it's going to do is look at that partition key and immediately figure out which partition it belongs to. So items that happen to be in the same partition, very efficient to query those together. So you can run this query operation, which is like a fetch many type operation, and saying, hey, if the PK is org hash Berkshire, how can I do that? You know, it's going to say, okay, these items are located on partition 3. I can go get those very quickly. So item collections, an important DynamoDB data modeling concept. One thing you'll note here is I can have different types of entities in the same item collection. So in this item collection, I have the organization entity up top, and then I have the user items below. We'll see in the next section why you might want to do that, some interesting things you can do with that, but you can sort of mix and match these items as you need to. All right. Last implication I do want to talk about in this sort of SQL versus NoSQL stuff is you just need to get comfortable with denormalization. And I think this is one of the harder parts for folks coming to DynamoDB data modeling, right? Because they're used to the SQL relational normalized world, and now you need to denormalize a bit. You don't have joins, you don't have some of the other constraints. So get comfortable with denormalization. Use normalization when it makes sense, but also don't feel too scared to sort of walk away from that. So with that, we're going to head into one-to-many relationships. I'm going to take a drink. And okay, so we talked about some sort of theoretical stuff around how you model data in Dynamo, some of the differences between it. We talked about partitions, things like that. I like to bring it back down to earth with one-to-many relationships because, if you've worked with applications before, you've probably designed one-to-many relationships. You have a good idea of how to do that in a relational database. I think it's helpful to see how we might do that in DynamoDB. So first of all, what is a one-to-many relationship? It's whenever you have some sort of parent entity that has multiple related sort of child entities, right? So it could be an office and employees, right? Multiple employees work at the same office, one-to-many relationship between that parent office and the child employees. It could be in an e-commerce store, a customer makes many orders. That parent customer makes many orders from your store, at least you hope they do because you want to stay in business. So there's a one-to-many relationship between that customer and the orders. Or in the example that we already showed in that SaaS application, right? An organization, a parent organization entity is going to have many users that act on behalf of that organization within our SaaS application. So that's what I'm talking about with one-to-many relationships. Let's talk about how we model them in DynamoDB. And I like to walk through 5 different strategies. And it's kind of interesting because in a relational database, there's generally one way you handle these. Whereas in DynamoDB, I have 5 sort of common ways. You can actually make other ones as well. So it's a little different there, but let's talk about those different strategies, show an example, and show when you'd want to use that particular strategy. So first strategy here is denormalization with a complex attribute. And I want to just go back to our SaaS example that we had before. Remember, we had organizations and users. I'm going to add a third entity into this mix, and let's say we have payment plans. So payment methods, excuse me. So when an organization signs up, they have to say some way they're going to pay for it. And then we allow them like multiple ways to pay, right? And so they put up their credit card, but if their credit card bounces, they can also have their bank account as a backstop and make sure they don't lose access, things like that. So an organization can have multiple payment methods. And this is the way we're going to model it. It might be kind of small here, but I'm going to outline it in red. What we've done is on our organization item, we've added this new attribute called payment method. And if you look at the value there, it's a complex attribute. It's a map, right? So a dictionary, something like that, that has multiple different payment methods. I have my default method and I have a backup method, things like that. So I'm storing that in this payment method attribute on DynamoDB. So this is a denormalized pattern here, because generally what you're going to do in a relational normalized scenario is if you have a complex value in a column, you'll split that out into a different table. You'll get it down to where each column has like a scalar value. You'll point back with foreign keys, primary keys, things like that. But when would we want to use this sort of pattern, this denormalization plus a complex attribute pattern? I think it's good when two things are true. Number one, you don't have an access pattern on that related item directly. So in this case, right, we don't have any access patterns where we're saying, hey, I have this particular credit card or this particular bank. I need to figure out who it belongs to, something like that. The only time we're accessing those payment methods are probably two. Number one, at the end of the month, you need to bill every customer. So you roll through and you say, okay, Berkshire, pull that Berkshire entity, look at its payment methods and run through those, right? So we're accessing by the organization there. The second one would be the user when they're viewing their payment methods in the admin screen of our application. They could see those different things. But again, that's within the context of that organization. It's not outside of that. We're never asking, whose credit card is this, things like that. So we don't have an access pattern on the related item directly. The reason that's important is because you can't index a complex attribute like that. So you can't have a secondary index on a map or a list or a set, something like that. The second thing you need to consider here is make sure you have a limited number of related items. And that's because DynamoDB items have an item size limit of 400 kilobytes, which is plenty of room for almost every access pattern. But if you're storing a relation here that could be unbounded, you could get in trouble. So one of the other one-to-many relationships I mentioned is customers and orders, right? So imagine if Amazon, every time I made an order, stored it in this sort of attribute on my customer item. At some point, we keep coming back making all these orders. We might exceed that 400 kilobyte limit, and you don't want to go back to that customer and say, hey, sorry, you can't make any orders because I screwed up my data model, right? I have a bad data model. So in this case, we're not going to have an unbounded number of payment methods. No one's going to sign up for 10,000 payment methods. You could reasonably limit a organization to say, hey, you get maybe 2 or 3 or 5 payment methods, but you don't get more than that. So it's reasonable to use this one here. But that won't work in all scenarios. So we will look at other strategies for one-to-many relationships. The second one is denormalization and duplication, right? And in a relational database, you don't want to duplicate data. When you have some data that's duplicated, again, you want to usually shuttle that off to another table and sort of point to it in some way. So let's look at an example here. Imagine I have a bookstore or a library, something that holds books in it. And my relationship is authors and books, right? And an author can write multiple books. There's a one-to-many relationship between authors and books. So in this table, I have a couple books by Stephen King. I have It and The Shining, and then I also have J.K. Rowling, Harry Potter, things like that. Now, when you're fetching that book item, sometimes you want some information about that parent item. So that parent item, that author, right? How do you handle that? And what we've done is I've just duplicated some of that information from the parent item onto its child items, right? So in this case, each of those books, It and The Shining, contains the author birthday on it, contains Stephen King's birthday on it. So I've duplicated some of that data rather than normalizing it and storing it on a different author-specific item, with Stephen King on it. So in this case, that's what we're doing. When is it a good idea to do some of this denormalization and duplication pattern? I think it's good in one of two scenarios here. First of all, if that duplicated data is immutable, right? Normalization, not duplicating data, is beneficial because it helps with data integrity. But if that duplicated data is immutable, you don't really need to worry about that. So in this case, Stephen King's birthday, it's the same today as it was yesterday, as it will be tomorrow. You don't need to worry about sort of changing that sort of thing in data integrity issues there, which is nice. But even if that data isn't quite immutable, but hey, maybe that duplicated data doesn't change often. It changes maybe once or twice a year at most, and or it's not replicated very much. Maybe it's only replicated across 2 or 3 items, and it's easy for me to go find those items and change it if it happens. But if you get in the scenario where it can change sort of ad hoc, willy-nilly, things like that, and then also it's replicated across a lot of items, this probably isn't going to be the best strategy for you. I'd look for something else in that case. So that's our second strategy, denormalization and duplication. Let's get into our third strategy, which is the composite primary key and the query operation. And I want to go back to that example we had before. Uh-oh, did my video just go out? Sorry if my video went. I don't know what's going on there. Alex, can you see me all right?
You have dropped off, but I can just present the screen if you want.
Oh, there we go.
You're back.
My camera got tired. Didn't know it was being used. All right. Anyway, let's see. So let's go back to that composite primary key and query pattern here. We'll go back to the example we had with our SaaS application. And imagine we had an access pattern that said, get all the users for a particular organization. And when you're doing that, you also want some information about that parent organization itself, maybe to return with that. So what we can do here is we're going to sort of co-locate the user items with its parent organization items in that same item collection. We talked about that item collection earlier. We talked about sort of co-locating it. And what we're doing is pre-joining our data so that it's all ready for us at read time to get that organization item and then to get all the user items that belong in that organization. So this is a pretty common pattern that you'll see if you have that sort of fetch many type access pattern, but you want to also get some information about the parent. That's a great pattern there. Let's move into the fourth pattern, which is secondary index plus query. And this is actually very similar to the last pattern. And we'll see when you would use that pattern. So let's go back to our example. We have our SaaS application with organizations and users. Let's add a third entity into the mix. Let's say we want to add tickets, right? And tickets can belong to a particular user. So maybe our SaaS application is like Zendesk or something like that, right? Where tickets belong to a particular user. I'm not sure. But maybe you have sort of the same access pattern we just talked about where you have, hey, get all tickets for a user, but you also want to get that user. So you might do something like this, where you insert the ticket items right here, right in the middle of your item collection. And now if you look at how this is set up, you can see in your item collection, you have your user, you have Charlie Munger, and you also have these two Charlie Munger tickets right there. And you can make a query that goes and gets those efficiently, and it all works. But there's a problem with this, right? If we go back to that access pattern we just had, we want to fetch all the users for a particular organization and also fetch that organization item. We co-located those near each other. But now with our new table, with our tickets in there, you can see it's our item collection is all jumbled, right? Where we have the organization item, we have the user item, then we have a bunch of ticket items, then we have the next user item and a bunch more ticket items, user ticket. So if you're querying this to get all the users, you're getting a bunch of extraneous tickets in there too. So you don't want to do this pattern because it's making your original pattern inefficient. So what we'll do instead, let's structure it a different way. We'll go here. We've put our ticket items on the bottom of our table here. They're in a totally different item collection. You can do individual operations against these. But then when you want to handle that other pattern, what we've done is we've added these attributes called GSI1 PK, GSI1 SK. And what those stand for are Global Secondary Index 1 PK, Global Secondary Index 1 SK. So just like what we're doing is we're adding a secondary index here. And we're giving it those generic primary key attributes, PK and SK, just like we did with our main table. You can also see here that the user item and the two ticket items for Charlie Munger, they have the same GSI1 PK value. And what that means is when we go to our secondary index, those items are all going to be located together in the same item collection. You can see we have our user item, we have our ticket items. We can get those all together in one query, satisfy it just in the same way we had with our composite primary key and query operation. So this is a good one when your primary key is already being used for something else, whether it's being used for that pattern in 3 composite primary key and query, or used for some other reason. You can sort of reorganize it into this secondary index and use this pattern there. All right. Last relationship here, let's talk about composite sort key. So we talked about a composite primary key, but this one is composite sort key, where we're putting multiple values into the sort key value and sort of smashing them all together. So if you look here, imagine I have stores and they have locations all over the world, different places. What I'm going to do is jam multiple values into that sort key, where it's state, then the pound sign, then city, then pound sign, then zip. And it allows me to search at a lot of different levels here, right? So if I want to find all the stores in a particular country, I could say, hey, partition key equals USA, and I can grab all those particular stores. But maybe I want to search within a country to a particular state. I want to say, the state of New York. How would I get all the stores in the state of New York? Well, now I can make a query where I'm saying partition key equals USA, and the sort key begins with NY, right? New York. So I'm getting all of those particular items. But maybe I want to get even more specific like that. In some cases, I want to get it into a particular city. So I want to get New York City. So I get New York City, but I don't get Albany. I think video went out again. I'm going to keep rolling here. So I could do that here and just say, hey, make that sort key start with New York hash New York City. Or maybe I want to get down to a particular zip, and I can do that as well. So I can search at different levels of granularity here. And that's the important part for the composite sort key. You have multiple different levels of hierarchy. We have country, state, city, zip, and you want to search at all these different levels. And when searching at a level in that hierarchy, you want all the sub items as well. So in this case, if we're searching for a state, we want to get all the items at lower levels. But this wouldn't work for that example we had in 4, where we had multiple levels of hierarchy with organizations and users and tickets. But when we're searching at that one level of organizations and users, we don't want to fetch all the tickets with it as well. So we don't want to do that, and that's why this pattern didn't work there, but it can work here. So summary, and then I'll try and get my camera back on to see if we have any questions. But summary, just a quick review of what we talked about today. Start off with why DynamoDB and serverless. You're seeing a lot of people use DynamoDB and serverless applications. We talked about the operational and sort of non-data model reasons why that's the case. If we're sort of bought into that at that point, then we talked about the basics of DynamoDB, data modeling. We gave vocabulary. We talked about SQL versus NoSQL, some of the principles of DynamoDB and NoSQL and what the implications of that are. Learned a little bit about single table design, and then brought it back down with some practical examples, one-to-many relationships. How do you model those out? Different strategies there. And then happy to take any questions if there are, and I'll try and get my camera back on in the meantime.
So we do have one quick question here from Adrian. He says, hey, Alex, after seeing the presentation from Matthieu of Lyft, what would you like to see out of an implementation of a DynamoDB construct? Like, what areas are there to make it simpler?
Yeah, that's interesting. I mean, I think that's a good one. I think you could tie a few things together. Like, one would just be around the billing model. Maybe by default, the billing model for a serverless DynamoDB table would be on demand, just because I think a lot of people are using on-demand and serverless applications. So that'd be nice. It's also some of the syntax in CloudFormation for declaring your primary key, declaring your secondary indexes is a little verbose. I think you could make that easier in a Lyft construct, and it's, especially these conventions of PK and SK. You could do that pretty easily if you could just say, hey, I have 2 secondary indexes. It would declare all those for you, all that stuff. That'd be nice. And then the next 2 things I would say is Dynamo has a feature called global tables, which allows you basically to set up these tables in multiple different regions, and they'll replicate both ways for you. So if you write something to your table in EU West 1, it'll copy that data over to US East 1, and same thing back and forth. So if you could easily set up global tables, because that sometimes has a lot of configuration. And then finally, there's a feature called DynamoDB Streams, where every time you write into DynamoDB, so if you do a new item, if you update an item, if you delete an item, they're basically going to put a record of that change into a change log, DynamoDB Streams, and you can process that and put it in your analytics system, feed it out to other services, things like that. I think if that was set up pretty easily, and you could just sort of define a handler in line, like Matthieu had with the queue example, I think that would be very nice. So I think there's a few different ways where these common patterns or common config you could encode easier into DynamoDB.
Yeah, your idea of Dynamo Stream straight into a data lake or something sounds like it'd be really cool. Yeah. Your point about like people usually defaulting to on-demand pricing, is there any reason you would go permissioned? Why do you see people not choose on-demand?
Yeah, so I think I was saying, like, on-demand pricing is going to be about almost 7 times more expensive than fully utilized provision capacity. But again, the problem being a lot of people don't know how much capacity they're going to need, so they often vastly over provision, and they also have a lot of variability during the day, week, month, things like that. So they're not getting full utilization out of it. But if you have a high scale application and you know your usage patterns pretty well to where you can get 80-85% utilization out of it, you can save a lot of money doing that. I just wouldn't recommend it for a lot of new folks if you don't know how much you're going to use. Like, use on demand for quite a while first and understand your patterns and your usage patterns. And then if you can do the math quickly and say, okay, this is how much we would spend on provision, you can flip it to provisioned if you want. That's one thing about Dynamo tables too, is you can flip it back and forth at will, almost at will. You can do it, I think, a couple times a day, but not, every minute or something. But you can change that as you need. So in that case, you might find out you can save some money, but I always recommend to people start with on-demand until Dynamo is like a meaningful part of your bill. And, if Dynamo is less than $10 or $100 a month, it's probably not worth the time even thinking about it, compared to what your engineers could be doing instead.
Yeah, that makes a lot of sense. For people that are getting started, where do you recommend they go after this talk? I was a big fan of reading your book, but do you have any other resources?
Yeah, I think the AWS resources are pretty great. You can check out those. I've got DynamoDB guide, which is totally free. You can check that out. The book has a free preview. You can check that out as well. And then I just, if you like video talks and things like that, check out the reInvent talks from Rick Houlihan. That's how I got into this stuff. He has some really great talks, and I've done reInvent talks the last couple of years as well. So I think there's some good content out there. Just go check that out. I have a repo, awesome DynamoDB in GitHub, and it has recorded talks. It has written material, just different things like that. So go check that out.
Nice, awesome. Well, thank you very much for joining us today, Alex, and also thank you to Matthieu earlier. I'll let you go, and we'll see everyone next time. We'll do another meetup next month in July.
Awesome. Thanks for having me, Alex.
Thanks. See ya.